Our solar system is a truly magnificent place. It is our home in the vast expanse of the cosmos. At its heart lies a single, brilliant star, the Sun. Around this star, a family of planets, moons, and countless smaller objects gracefully pirouette. Let us embark on a serene journey through this cosmic neighborhood. We will travel outward, step by step, from the searing heat of the sun to the cold, distant frontiers of space. Imagine yourself floating, watching each world reveal its unique character. This is a story of immense scale, fire, ice, creation, time. It is our story, written in the stars. We begin our tour at the very center of it all. The Sun is not a planet, it is a star, a colossal sphere of incandescent gas, primarily hydrogen and helium, locked in a continuous, furious dance of nuclear fusion. This process releases a staggering amount of energy, which radiates outward as the light and heat that sustains our entire system. Without the Sun's constant life-giving energy, Earth would be a frozen, barren rock. The Sun contains more than 99.8% of the solar system's mass. Its gravity anchors every planet, from tiny Mercury to giant Jupiter in its orbital path. This journey is a simple one, really. We are just following the light. The planets do not generate their own light. They reflect the light of the Sun. Our first stop is Mercury, the closest planet to the Sun. It is a small, dense world, not much larger than Earth's moon. Being so near the Sun, it endures extreme temperatures. By day, the surface can scorch at over 400 degrees Celsius, hot enough to melt lead. But with almost no atmosphere to trap that heat, nighttime temperatures plummet to about -180. Its most surprising feature is its strange rotation. A single day on Mercury is actually longer than its year. Next, we glide onward to Venus. In many ways, Earth's twin, nearly the same size and rocky in composition, but the resemblance ends there. Venus is shrouded in a thick, toxic atmosphere of carbon dioxide and sulfuric acid clouds. The extreme greenhouse effect makes it the hottest planet, around 465 degrees Celsius. It rotates backward. The Sun would rise in the west and set in the east. We now arrive at a familiar sight, Earth, the third planet, our home. A vibrant blue marble defined by liquid water and a protective atmosphere rich in nitrogen and oxygen. Our life-sustaining air is very thin. If Earth were an apple, the breathable layer would be thinner than the skin. Leaving the rocky inner planets behind, we encounter a vast region known as the asteroid belt. This is not a crowded, chaotic field of tumbling rocks as in films. In reality, it is an enormous, mostly empty ring. Populated by millions of asteroids, rocky remnants, metallic remnants, left over from the formation of the solar system some 4.6 billion years ago. These objects never coalesced into a planet. Jupiter's immense gravity prevented it. Space between individual asteroids is vast. A spacecraft could fly through with little collision risk. They come in all shapes and sizes, from tiny pebbles to bodies hundreds of kilometers wide. The belt marks a compositional dividing line. Small, dense, rocky planets inside, colossal gas and ice giants beyond. A graveyard of planetary building blocks, a frozen record of the solar system's youth. One object stands out, Ceres, nearly spherical from its own gravity, classified as a dwarf planet, with a rocky core and a mantle rich in water ice. Perhaps more freshwater than on Earth. Gather all the asteroids and their mass is only about 4% of the moon's. Dust of a planet that never was, not the remnant of one destroyed. Crossing the asteroid belt, we arrive in the realm of the giants. The first and largest is Jupiter, the fifth planet from the Sun. A gas giant composed mainly of hydrogen and helium, the same elements as the Sun, so large that all other planets could fit inside it. Its most famous feature is the Great Red Spot, a colossal storm raging for centuries, larger than our entire planet. Jupiter's gravity acts as a cosmic bodyguard, deflecting comets and asteroids that might threaten the inner planets. Next is Saturn, also a gas giant, famous for its breathtaking rings. Countless pieces of ice and rock ranging from dust grains to mountains. Saturn is the least dense planet, so light it would float in a bathtub large enough. We now venture into the cold and dark. Uranus, an ice giant composed of water, methane, and ammonia ices around a small, rocky core. Its pale blue comes from methane absorbing red light. Most bizarrely, Uranus is tilted on its side, rolling along its orbit and producing extreme seasons. Our final major planet is Neptune, the eighth and most distant, an ice giant of deep azure blue, the windiest planet, with storms exceeding 2,000 kilometers per hour, cold and dark due to its distance. Neptune's largest moon, Triton, orbits retrograde, likely a captured Kuiper Belt dwarf planet from long ago. Our tour does not end with Neptune. Beyond lies the Kuiper Belt, a vast icy frontier, like the asteroid belt but far larger and more massive, extending far out into the darkness, home to countless icy bodies and many short-period comets. Within this belt we find Pluto, once called the ninth planet, later reclassified as a dwarf planet after discoveries of similar worlds. Pluto is a complex world of ice and rock, with a thin nitrogen atmosphere and vast glaciers, including a giant heart-shaped plain of frozen nitrogen. The Kuiper Belt hosts several dwarf planets: Haumea, flattened by rapid rotation, Makemake, a large reddish world, and far beyond Pluto, Eris, slightly smaller but more massive, whose discovery helped redefine planet. These worlds can be active and dynamic, challenging our ideas of planetary evolution. Beyond the Kuiper Belt, scientists theorize the Oort cloud, not a belt, but a gigantic spherical shell of icy debris that may extend almost a quarter of the way to the next nearest star. It likely births long-period comets taking thousands or even millions of years to orbit the Sun. We have never directly seen the Oort cloud. Its existence is inferred from the comets that fall inward. These visitors give us brief, brilliant glimpses of messengers from the solar system's most distant edge. Out here, distance becomes poetry, and time becomes a sea. Our tour across the solar system reveals a profound truth. We live in a place of incredible diversity and wonder. From the scorched plains of Mercury to the icy heart of Pluto, each world tells a part of a larger story. We have seen hot, rocky planets forged in sunlight, cold, gaseous giants grown in darkness, and belts of ancient debris with mysterious dwarf planets. Variety emerges from gravity, chemistry, and time acting over billions of years. For millennia, planets were wandering lights. Today we peer through powerful telescopes and the eyes of robotic explorers, rovers on Mars, orbiters at the giants, and probes that have flown past the distant Kuiper Belt. Each mission returns data that rewrites our textbooks and informs how planetary systems form and evolve. Not just ours, but countless others across the galaxy. Studying the runaway greenhouse on Venus refines our understanding of Earth's delicate climate. Searching Mars for past water asks fundamental questions about the origins of life. Every distant discovery gives us new perspective on our liquid oceans, breathable air, and thriving biosphere, a reminder of what we have and must protect. The solar system inspires us and challenges our ingenuity, a frontier for future generations. One day, humans may walk again on the moon and perhaps on the red soil of Mars. We will send probes farther, read the first chapter of a far grander book, and keep looking up, keep asking questions, and keep exploring.